Bonjour. Well, that's the way we say hello in France. Hello, children. How are you people doing? I'm saurabhkumardutt, and I'm here to teach you people a little bit of mathematics. Now, children, this fantastic place that you get to see is actually the Brittany coast in France. It's a place which is dotted with ancient fortress cities, jagged cliffs, pebbled beaches, and a peninsula which is rich in maritime heritage. Make sure to visit this place because this place has to offer the good French seafood, which comprises of the conchial oysters, the kep pancakes, and all of this is to be sipped with a fine glass of apple cider calvados. Make sure to visit this place, and all the people of France that you get to meet, don't forget to tell them bonjour. In this note, children, I'm going to start off this lecture of mensuration, which is the third one, where we are going to discuss sums on cubes and cuboids of a little different type. Make sure to revise all the formulae that you've studied earlier, and then to try out all of these sums before I discuss them. Discussing the sum with you people. Now, initially, I'll be giving you people a reading so that if there is any doubt, I will clear it up. Now, there's some Shanti sweets which requires a cardboard box, right, of size 25 into 20 into 5, all being in centimeters, and 15 into 12 into 5, all being in centimeters. So these are two type of boxes which this sweet house requires, right, for packaging its sweets, right. I'm sure everybody must be sweet tongued, right, and everybody likes sweets. Even I really love a lot of sweets. I can just name one or two. I love many sweets, right. So if we have 5% of the cardboard which will be used up for folds, right, because you know that when cardboard boxes are made, right, they have to be folded on top also so that they hold up, right, the box as a lid, right. And further, you've been given that the cost is rupees 4 for 1000 centimeters square, right. Then you got to find out the cost that this sweet house has to pay for 250 boxes of each kind. Now remember, there are two type of boxes which are to be made, and there are 250 boxes of each of the types which have to be made. So the total number of boxes which these people are ordering will be 250 plus 250, that is 500 boxes. So now that you know the question, so I give you people 10 seconds for trial. If you want more time, then you can pause the lecture and take more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay guys, now let's discuss the sum. In the question, we've been given that there are two boxes of different sizes, right? So what we can do first is we can find out the area which is required of both of these boxes, right? So we can name the first box to be, say, some B1, right? So if we talk about the total surface area first, we will talk about the formula for the total surface area, and as this is a cuboid, you've already learnt the formula of this, so quickly try telling it with me. It is 2 times of LB plus BH plus HL, where LB and H are the length, breadth, and the height, right? So let us name the first box to be, say, some B1. So if we talk about the total surface area of the first box, or the amount of cardboard which is required to make the first box, then that is going to be 2 times of length being 25, breadth being 20, right, plus length being 25 and height being 5, plus breadth being 20 and height being 5. So this is the total surface area in centimeters square of the first box. Now if we talk about the second box, let us name it by B2. So the second box will be having the total surface area as 2 times of the length being 15 into the breadth being 12, plus we have the length being 15 into the height being 5, plus we have the breadth being 12 into the height to be 5, right? So this is how we can find out the total surface area of the second box also. Now remember children, this is also going to be in centimeter square as all the dimensions are in centimeter. Now this is box 1 plus box 2. Remember there are 250 boxes of each type, and whatever total surface area comes to be, we've got to add 5% more so that that can be used up for different folds, right? So if we talk about the total surface area, the total surface area is going to be capital A, say, so we will have that to be B1 plus B2, right? And we will further multiply that with 1 plus 5 upon 100, where 5% has been extra given for folds, right? So here further we can calculate this. So we have 2 times of 25 into 20, right? We can calculate each of these, but better than that, what we can do is we can take few things common outside. So let's first write what these stuffs are. So here we find that from the first bracket we can take 5 to be common outside. So if we take 5 to be common outside, then inside we'll be left out with 5 into 20, and 5 twos is 10, so we get 100 which is left within. And then further again, when we take 5 outside, we will have 5 into 5 which is 25. And then when we talk about the next term, taking 5 outside, we are just left out with 20. Now children, to this we are going to add the next one, that is we will add the area of the next box. Now here also we find that 5 can be taken common outside, so we have 2 into 5 which can be taken common outside, and inside then we'll be left out with 3 into 12 which is 36, plus we have 15, plus we have 12 which is going to be left over, right? And remember, all of this is going to be multiplied with 1 plus 5 upon 100, which can be written as 105, right, divided by 100, right? So this becomes the total surface area of both the boxes, right, along with 5% of extra area of the cardboard which can be taken for folds. Now further children, calculating this, we can write this to be 5 into 2 which is 10, which can be taken common outside. So we have 10 times of this 105 upon 100 can be written on the left hand side, and further then we will be left out with 100 plus 25 plus 20 which is 145, right? To that is going to be added, here again 10 has been taken common outside, so we have 36 plus 15 plus 12. 15 plus 12 is 27, and 6 is 33, and 30 is 63, right? So both of these are to be added together. 1 0 can be cancelled from the numerator and from the denominator, so we are left out with 105 divided by 10, and this is further multiplied by 3 and 5 is 8, and 6 and 4 is 10, one remainder. So we have 208 which is to be multiplied with 105 divided by 10, and all of this, remember, is in centimeters square. So this is the combined area of a pair of the boxes of different types, to which 5% has been provided extra for the folds. Now remember, there are 250 boxes of each kind which have to be provided. As such, both of these added up together can now be multiplied by 250. So now you can say this area which is to be multiplied by 250 will become equal to 105 multiplied by 208 divided by 10, which is further to be multiplied by 250, where 1 0 gets cancelled. So further that comes to be 105 multiplied by 208, which is further multiplied by 25. Now after this, if you talk about the cost, right, for the cost, as the cost is 4 rupees for 1000 centimeters square, right? So here we will be employing the unitary method, right? We will say that as we require to find out the price, so the price has to be on the right hand side. So we will say that for 1000 centimeters square, the prices rupees 4. So we'll talk about 1. So for 1 centimeter square, the price will be right upon left, that is 4 upon 1000, right? Now children, we'll be talking about for this amount of area which we've just calculated. So we have for A into 250, right? The price is, and here children, we have 4 upon 1000, which requires to be multiplied with 105 into 208 into 25, right? So further we've got to calculate this. So 4 cancels 1250 times. Now 25 cancels 250 10 times, right? So further we just have to multiply 208 with 105, and then we just have to shift a decimal. So 5 eighths is 44 remainder, then we have 5 twos is 10, then we will shift one place and one more place for 0. Thus we have 802, which has to be written here, and then we add up these, so that becomes 0 4 8 1 2, right? So we have this as rupees 21840, which is to be divided by 10, as 10 was there in the denominator. Thus we have it to be rupees 2184, right, which becomes the final answer which this Shanti sweet house has to pay so that they can get the boxes. So children, I'll just quickly discuss the sum all over. Again, in the question you've been given here that there is a sweet shop which wants to make some sweet boxes for packaging some sweets. Now there are 2 sizes for which it requires boxes. The first is 25 into 20 into 5 in centimeters, and the other is 15 into 12 into 5 in centimeters again. Now 5% is provided extra for packaging, that is for making the fold so that the top lids can be made so that they can hold the sweets well, right? And after that you've been given the price, that is, it is rupees 4 for 1000 centimeters square. Now the total cost which this sweet house has to pay is what we've got to calculate. Now as we've got to make these rectangular boxes or cuboidal boxes, we talk about the total surface area formula which is going to be employed, and that is 2 times of LB plus BH plus HL. Now here for the first box, when we employ the formula keeping the values, we have here 2 times of 25 into 20 plus 25 into 5 plus 20 into 5, which is LB plus BH plus HL in accordance with 25, 20 and 5 being the dimensions. Then for the second box, as the dimensions are 15, 12 and 5, so we have 2 times of 15 to 12 plus 15 to 5 plus 12 into 5, right? Now both of these are going to be in centimeters. Now remember, when we talk about the total surface area of both of these boxes added together, that can be written as B1 plus B2, and as 5% extra is to be provided, so that thus becomes equal to times of 1 plus 5 upon 100. Now next guys, after this, if we talk about the total surface area thus calculated, so we can keep these values, but remember, when we are to do calculations, then we will try and make them a little simple. That is, we will have here 5 taken out from the first bracket, right, which will give us 5 into 2 as 10, and then again from the second bracket we can take 5 common outside, which will make it 5 into 2, that is 10 common outside, and thus calculations will become pretty simple. Now 5 being taken common outside, we are left out with 5 into 20, which is 100 plus 25 plus we have 20. Now 20 plus 25 is 45, added to 100 will give you 145. Then from the second bracket, again when you take 5 common outside, we have 5 into 10, which is common outside, and inside we have 12 into 3, which is 36, right? Plus we have 15, plus we are left out with 12 in the third term. Now adding these, we have 15 plus 12, which is 27, plus 6, which is 33, and 30, which becomes equal to 63. Now adding up both of these terms, we have 3 and 5, which is 8, 6 and 4, which is 10, 1 remainder, we have 208. And remember children, this is multiplied with 1 plus 5 upon 100, which can be written as 105 upon 100. And in both of these brackets, we have taken 10 common So as such, from both of these terms also we can take this 10 common outside, right, as this is one term and this is the second term from which 10 can be taken common outside. Now both of these zeros are cancelled from the numerator and from the denominator. Then we have 105 upon 10, which is multiplied with 145 plus 63, which can be written as 208, which is multiplied with 105 upon 10. Now further, at the moment we don't calculate further, but we've been given here that these boxes are to be 250 for each of these cases. So we multiply this area that we found out with 250, right, and further here one more zero gets cancelled, and at the moment we keep our calculation withstanding, so that if there is something to get cancelled, we'll cancel that off, and thus the calculation will become simple without having to multiply. Now here we've further been provided that for every 1000 centimeters square, 4 rupees is to be provided. So here we've got to employ the unitary method. So we will say for 1000 centimeters square, the price is rupees 4. Now, why are we writing this way, and why is it not this way, that rupees 4 has to be provided 1000 centimeters square? That is, the cost or the price is what is in question, and that is why we've kept that as in accordance with the rules of unitary method on the right hand side, right? As such, here the price, which is rupees 4, has been kept on the right hand side. Now we will say for 1, that is for 1 centimeter square, the price is 4 upon 1000, and thus we will further say for A into 250, which is the area, right? What we do is, if we talk about the price, then that is going to be 4 upon 1000, which is to be multiplied with 105 into 208 into 25. Now further here, 4 cancels 1000 250 times, right? And then further, if we talk about 25 cancels 250 10 times, right? And thus we just got to multiply 105 with 208, right? And when we multiply it, we will get here 5 8s are 40, 4 remainder 4, and 5 2s are 10, and then we will shift a place and one more place for 0. As such, multiplying by 1, we will just copy all of these, that is 802. And now when we write this comes to 04812, so 21840. This becomes the total price, right, which has to be paid, but this finally also requires to be divided by 10. As such, rupees 2184 is the price which has to be paid by this sweet shop to get all of these 500 boxes of the 2 different types, right? So is everybody clear about this, Pankaj? For sure. That's good, guys.